a demo of one analytical application that I have built with ClickHouse. So let's see. Why did I do this? First, it is just for fun, just for testing ClickHouse to find something unusual, to check if it will break on my database. Second, it was an internal company contest that we organized for our offsite event. So I announced at the contest that everyone should implement some nice looking application with ClickHouse. And I participated in this contest. Some of my colleagues participated in this contest. And as a result, we had at least one application from me. I did not receive any prize. I did not receive any bounty for this, but it was interesting. So what we will need? We will need some interesting idea. We will need a nice data set and a way to analyze and visualize this data set. And how to get a nice data set? We can get it from social networks like Reddit. Reddit provides its data as a database dump. You can upload it into ClickHouse. You can analyze it. Twitter does not provide a database dump, but apparently it is available on Internet Archive with questionable legal status. But still, if you want to use it for your personal need, try it, upload into ClickHouse, and calculate how many times Elon Musk did something. Stack Overflow provides official data dumps. You can load web crawls like Common Crawl into ClickHouse and make your own version of Google. It is possible. There are some databases from public sector, like from New York Police Department. I'm not sure if it will be available for a long time since now, so hurry up, download it, and you will be able to do something. Wikipedia provides OpenStreetMap. There are open datasets from some temperature sensors around the world. And there is a catalog of example datasets in the ClickHouse documentation. But what I will use a dataset about ADSB. It is Automatic Dependent Surveillance Broadcast. Not sure if it is clearer from this description. It is actually the data from airplanes, helicopters, anything that flies, drones, most of the drones. And this data is broadcast by radio, by transponders located on these flying things. All passenger airplanes have to provide this data. Military airplanes also typically provide this data when they are not on operation, when they just fly from one place to another. They typically have transponders enabled. And this data is unencrypted. You can collect it just from software-defined radio. You can decode it, store it, and it will look like this. There are plenty of websites like Flight Radar 24 with this data. And if you just use your own radio and collect this data out of thin air, you will receive it from like hundreds of kilometers in this radius. If you want to receive this data from around the world, you have to use one of exchanges that collects this data from participants, and every participant can receive data from around the world back. And there are plenty of exchanges. ADSB.fi adsb.1, adsb.lol. I'm not sure why it is named this way. adsbhub.org, airplanes live, openflights.org, FlightAware, ADSB Exchange, Flight Radar 24, Open Sky Network. And I decided to use adsb.lol because it provides the dataset on GitHub by direct links without authentication, without any restrictions, with permissive license. And you can see every day you have about 1.5 gigabytes of data. So I have made a script. Just to download it and insert into ClickHouse. So how to do it? The data looks like this. A bunch of JSON files produced by some tools to decode this radio protocol. And it contains information about the metadata, about the type of airplane, like AT-76. Probably it is ATR or whatever. Yeah, it is ATR-72. -600 timestamp, and a bunch of traces. And every trace is a point in time and space, a location of this airplane, plus vertical speed, plus roll angle, plus this another type of angle, ground speed, air speed, everything. Even like flight number. Let's take a look in more detail. So to decode this data, I have to split this JSON file into data and metadata and then join back together. And I used the tool ClickHouse Local. You should already know what is ClickHouse Local. Who does not know what it is? It is like ClickHouse Server, but inside a command line tool. You can run any SQL query. You can connect to external data sources. You can transform the data without launching the server. So in this example, I will insert data into ClickHouse Cloud with the remote secure table function and with this insert into function query. And I will do some data transformation with select. For example, I will take a timestamp from metadata and add time offset to get the actual time point, select some fields, and just join cross product of these two JSON files with data and metadata. And I have a table where I insert this data, and this table contains all the fields that I extract. And additionally, it will calculate a grid. So I will split the coordinates, latitude and longitude, convert to Mercator map projection with some formula containing logarithms, tangents, pi, etc. It is just a formula from Wikipedia how to calculate Mercator projection. And Mercator projection is just what you see on whatever web maps like Google Maps, OpenStreetMap. All of them use a projection, name it Web Mercator. Also, I encode this projection as UN32 just to create a, I don't like floating point numbers, I will create a grid with integers and create indexes min max on top of these two coordinates. But what is really interesting that as a primary key, as a sorting key, I use not just these x and y coordinates from Mercator projection. I use this function named Morton encode. And what does this function do? Yeah, please.
Space filling curve.
Absolutely right. This is a space filling curve. So instead of sorting by just one coordinate and then by another coordinate, what I do? I will sort it in a way that it will go through the space. Interesting if I have an example. It will go through the space by mixing up these coordinates with each other. And it will take the first quadrant, then the second quadrant, third quadrant, and the fourth quadrant. And inside every quadrant, it will sort data again by splitting it by quadrants. It is like binary space partition. So the combination of this sorting order and these secondary indexes will allow to query the data in a particular area on a map. OK, it's probably better to be shown than told. OK, I have a table. Now what? I inserted everything into this table. It contained 50 billion records. Actually, this is incorrect because today it is 150 billion records. Around 1.6 terabytes. This is also incorrect because now it's about 5 terabytes. So what to do with this data? Obviously, something beautiful. I like when the data is beautiful. Let me show you a demo first. And probably some of you already have seen this demo, but some of you not. So let me.
Did you buy that domain after inspired by .lol?
No, adsb.lol is not mine. So what is it? It is actually Seattle, and not only Seattle. And what this demo does, here we have a query. This is a ClickHouse query. I have some aliases defined, and it will produce a result in raw binary format for every tile in a map with pixels. So this SQL query directly generates these pixels. Every tile is 1 million of them, and all of these queries are run in real time. I can edit this query, I can zoom in, I can change this query to filter. One example, let's zoom in and see where is Seattle Tacoma Airport, where is whatever, I don't know which airports. What? Somewhere should be Vancouver. I can even select something, and it will generate a report in real time about this data. Like I can check which airplanes were the most popular, and I can filter by these airplanes. Like, let's select.
Is that sorted by popularity?
Yeah, by popularity for this specific area, this specific airport. Let's select something like, it's not quite small, something unusual. Like this is quite rare. And now we filter this data by selecting only this particular airplane. Let's take a look how the query changed. The query changed here. So here is the filter. OK. Let's take a look at some other stuff. Like, what if I will filter and select only military airplanes? What will be the most used airport? Actually, there is quite a lot of traffic. Where is Boeing Airfield?
It's right between
Right
Seattle
by
and
Everett.
Where?
You want the downtown one or the Everett one, the main plant?
Everett.
Everett.
And
North, further north.
Keep going a little bit. Right.
yeah, I see it.
No,
Yeah,
I
and
live right off the runway.
Seattle
Yeah, that's
There it
airport.
is.
International. Let's filter by, let's color everything by the difference between Boeing and Airbus. And yeah, interesting what is here. So Boeing should be blue and Airbus should be red, or vice
I'm
versa.
not gonna find much Airbus up
Airbus is green, so Boeing is blue. Let me show what is here. Actually, it's not Boeing and not Airbus. It is something else. But Boeing should be right here. So we have a lot of 737, 737 MAX. Also, let's zoom in. And it's not a large airport, but still. And this is probably some hangar, aviation technical services. Okay, so everything works. If we select, for example, only helicopters, what it will show? Helicopters. And it should show some police stations.
down south by Joint Base Lewis McChord. You see quite a lot.
Let's check. It should also show some hospitals.
Oh, wow. They do each one's a disciple.
Yeah, that's quite interesting. And probably some attractions.
Or landings, huh?
Yeah, by the way, what is this? Some Seattle Center. Okay, let's stop playing with this map and look about the details. So, possible. First of all, ClickHouse has REST API, HTTP API included. You can query ClickHouse directly from an HTML page. You don't need any backend. Sometimes you do, but sometimes you can just get away without any backend. And querying is as easy as fetch with method post and your query in the body. If you need some advanced usage, you use a TypeScript driver. If you use any other language, you use a corresponding driver. Okay. ClickHouse has support for parameterized queries, and they are not parameterized queries like in other databases when you just type question mark and it will be whatever. We have type safe parameterized queries. Like in this example, you have a substitution of type uint16, another named substitution with type also uint16. And you can even substitute AST fragments, like here, table has a type identifier. And as a bonus, you can use these parameterized queries as a basis for parameterized views. And they are queryable like here, as a table function. Okay, another component, materialized views. For this particular demo, I created not just a single table, but 3 tables. One table contains all the data. Another table named sample 10, Plains Mercator sample 10. It will contain just random 1/10 of the data, and sample 100 will contain a random 1% of the data. And when I render these pictures, I first render just from a single percent. Then, when it is ready, I render 10% of the data. And when it is ready, I render 100% of the data. So my demo is responsible thanks to materialized views that create these sample datasets on insertion. Another point, ClickHouse has flexible and rich role-based access control. So for my website, I created a user with some settings. For example, this setting. Probably backend developers don't know what it is, but front and developers definitely do. It is to enable a specific HTTP header to allow querying this server from other origins. So it will, ClickHouse will answer with this header, and browser will accept this data. Some limitations on query complexity. The user will be limited as a read-only. I granted select to specific tables. And another user just to display a progress bar. Another component that made it possible is support for quotas and query complexity limitations. So what if I publish this website on the internet and it just gets abused by a single user? I don't want that. So I created a quota inside ClickHouse by IP address to limit the maximum number of selects and maximum amount of data to be read every minute, every hour, and every day. If you exceed this quota, it will just tell you, please wait 1 hour, you are querying too much. And another component, functional indexes. So in this example, this order by key is a functional key. Actually, it is a tuple of two components. The second component is time, and the first is this mixing of two coordinates. And these min-max indexes are created on top of materialized columns. That is also one interesting feature. It's like columns that are calculated on the fly, on insertion, and materialized inside the table. ClickHouse has a quite convenient, modern, friendly SQL language. So inside with section, you not only can specify common table expressions, you can also specify aliases, like here. And then you can use aliases in any place inside the query. For example, this expression references already defined aliases. It does not sound like a big deal, but in any other database, you don't find this feature. In ClickHouse, you do. What else? Query parameters. And for example, this nice feature. So I generate a picture with pixels 1024 by 1024. And what if in some pixels the data is not available? I will fill this data with this expression. In ClickHouse order by expression, you can specify order by with fill. And if your data is not continuous, so if you grouped by some field like integer, and the data is available for 1, 2, 3, and then like 5. If you specify with fill, ClickHouse will automatically fill number 4 with 0 aggregations. ClickHouse has support for, sorry?
Does that let me specify the fill value, or will it always be 0?
It will be the default value of aggregate functions. It could be, or the default value of data types. For strings, it will be empty strings. And by the way, you can override it. You can specify specific value. Yeah, and also there is interpolation. You can fill it so it will interpolate between different points. And obviously, ClickHouse has a rich set of data formats, about 70 different formats, including text formats, binary formats. In my demo, I used this format raw binary. It's like a raw format that you get from your photo camera, whatever. So if you have integers, these integers will be just put one near each other in little endian, and this is basically it. Compression out of the box. So it obviously stores data compressed. Also, it recognizes compression for external data when you import this data. When you export data, it will automatically compress based on the extension. And in HTTP, it will automatically recognize the headers like accept encoding, content encoding. So these pictures are actually, initially I thought that maybe I should generate PNG, pictures inside ClickHouse, or JPEGs. But then I figured out that I use these raw binary bitmaps, and if I compress these bitmaps with ZSTD, I was surprised, but it takes less space than PNG. Specifically for ClickHouse Cloud, infinite storage. So ClickHouse supports local storage and object storage and hybrid storage, and also external tables like data lakes. It can query data lakes, it can query external databases. And in ClickHouse Cloud, everything is automatically configured to use object storage as the main storage plus caching on local SSDs. It has support for parallel and distributed queries, and actually my website works quite fast because queries are spread across 10 machines, and they are parallelized across all of these machines and across all of CPU cores on every machine. It has query result caching, and I enabled it for my website, so some of these pictures are straight from the cache. ClickHouse has local and server modes. So the server used for real-time reporting, and ClickHouse Local is used for data preparation. And ClickHouse Local is quite easy to use and easy to install. There are similar tools for processing, data processing in command line, but I found ClickHouse Local, my own tool, the most versatile, the most convenient. And if you did not use it before, I strongly recommend to try. What else? So, you probably not need to be convinced, but trust me, and please tell your friends. ClickHouse is the best database management system for analytical applications. It is fast, scalable, resource efficient, easy to use. It is pleasant to work with, robust, reliable. It has everything included. And friends, tell friends to use ClickHouse. So tell your friends to try ClickHouse, to use it, to love ClickHouse. Thank you.
ClickHouse is awesome. Obviously, we all believe that. But we do have a need to write UDFs in Rust because our compiler is in Rust.
Mm-hmm.
Is that coming? Or else we have to plumb all the data out?
You know, it is interesting because you can write UDFs for ClickHouse in any language.
Oh.
Yeah, they work with the API is that you compile or just bring a script that will receive the source data in standard input, serialize it in any available format like native or Parquet. Yeah, it could be a binary, it could be a script. This binary receives a bunch of data to standard input and outputs a bunch of data with the same number of records to std out. You can write them in Rust. You can write them in Python. You can even use, what is the most obscure programming language? Zig, Haskell, BAML. Up to you. Actually, it's not a bad idea because BAML will provide structured inputs and structured outputs. And this is what is exactly what is needed for ClickHouse.
Exactly right.
Exactly.
That's cool.
Can we click the Elon Musk filter?
Yeah, sure. Let's do it.
That's the airplane. Where is that?
So,
Probably at Reagan.
just a disclaimer, it is not necessarily Elon Musk. I just asked it in Google, what are tail numbers of airplanes from Elon Musk? And some websites told me about this, but I cannot guarantee that this is that person. But it looks very plausible. So he flies from Bay Area somewhere in Texas, just a few times to Florida, New York obviously, and not only New York.
You can see where he turns his transponder off.
No, actually it is just when data was not collected by any receivers. And interesting, we can check what airports do he like. So most likely in New York it was not JFK, because why Elon Musk should use JFK? Yeah, should be some better airport. For example,
Looks like Newark. It's west.
Teterboro in New York.
Oh, okay. Better than Newark.
Yeah, interesting what was in Europe destinations. You know, actually I created this map even for me after some trip, but I did not publish it just in case. So in Europe, Berlin, for some reason, I don't know, but we can check when exactly did he visit Berlin, and it was two different types.
Can you plot the flight frequency against its stock price?
That's good data.
It will require a complex SQL query, and probably I will use some AI for that. But so what was in Berlin? It was 2022 April and 2023 November. I don't know what it was, but it looks plausible.
You'll be hearing from him tomorrow.
Hey, just cease and desist.
Let's take a look at something interesting. So Boeing with Airbus. Airbus are green, and Boeing are red, if I recall. And we will compare Europe and the United States. There should not be a big difference, because in the United States there are plenty of Airbus, and there is no restriction prevents companies buying Airbus in the United States and vice versa.
Not yet.
Wow, you can see the no-fly zones.
Yeah, there are some no-fly zones, and in the United States, for example, what is this triangle? Yeah, it's Area 51. And also interesting, if we take a look at Mexico, like what is this circle in Mexico? And it is near Mexico City.
Is it a mountain?
Yeah, it's a mountain.
Yeah.
But we can find a lot of interesting stuff. So feel free to try this service. I keep it around. It is available for everyone.
Does it update every day?
Yeah, it has real-time data.
Publish that as art.
So for example, let's filter by the current time, and we will do it. Oops, what did I press? 1 hour, for example. Let's check if it is actually updated in real time. Yeah, looks like it is. And we will select some data.
Can you filter by ground vehicles?
Yeah, sure. Ground vehicles in real time, right?
Yeah.
Why are there ground vehicles?
Yeah.
Semis. They all have transponders now.
Yeah, inside airports, there are some snow cleaning vehicles or baggage moving vehicles or
They don't crash.
yeah, and but not everywhere they have to enable transponders. In some countries they do, in some countries no. And sometimes I see interesting stuff like airport buses or sometimes, airport vehicles just go outside of airport and move across streets. And sometimes there are even towers in this category. What is TOW 902?
Because they move
Yeah.
planes.
Moving airplanes.
Yeah, probably.
Planes on the highway.
And the registration number is just SURF.
Service vehicle.
Yeah, a lot of interesting stuff.
Cool.
You didn't win for this? Who won?
Sorry?
Who won the competition? Entered company.
Actually, I was the only participant.
Very cool.
Alexey, did you try the Hilbert encode instead of the Morton encode for the index?
When I created this service, only Morton index was available, but now we have also Hilbert space filling curve, and
Is it a ClickHouse implementation?
inside, yeah.
Ah.
And it should give slightly better result, slightly better space locality. So yeah, this is a great idea. Probably we can implement re-index data with Hilbert curve. And it should work even slightly faster, but it is already quite fast, even for real-time data.
Do you have real-time alerts for drastic changes in altitude?
Yeah, it records vertical speed, and we can filter by really high vertical speed. But I found that, for example, if I filter by low ground speed and high vertical speed, I just get helicopters. If I filter by really high altitude, I found weather balloons.
Interesting.
And there is a filter by high performance airplanes that can go like this. And let's, so we have this filter. And where are high performance airplanes? What is this? Vancouver International. Let's.
Is it still ground vehicles? Or?
No, now it is high performance. Let's take a look.
So these are all fighter jets?
Interesting why this Beach King Air is classified as high performance. I don't know.
But that's just the area that he's looking
If we filter by military, what interesting we can find. Let's take a look. No, it's not military. Interesting. Some of Airbus 330 classified as military. Maybe.
They have normal planes too.
Here is correct result.
The Hercules there.
Yeah, we should be able to find some F-18s up in Whidbey.
Oh, this is interesting. Let's filter by,
Oh, the fueling jet.
yeah. Let's filter and take a look across all the United States.
Is that all Colorado?
They are colored by the speed and altitude. So when they are higher in the sky, it will be bluish and red. And we have some errors. Because I have enabled one experimental feature on this service just recently, distributed cache, which is not available for production. So I have to either disable distributed cache. Okay, and these refuel airplanes, for example, they fly outside of Virginia. There is some military base just a bit to the ocean, and they circle around, waiting for something.
They do a lot of naval practices out in that area.
Yeah, and also if I filter, for example, by, actually, let's again filter by military, and you see a lot of interesting stuff like here. And I don't know what it is, but most likely it's there are some areas dedicated for training purposes. So they fly to this area and inside do some exercises, probably. But I'm not sure.
That's not a different thing, it's just a lot of traces?
Yeah, just a lot of traces accumulated, aggregated.
Wow.
You need a UFO filter.
Unfortunately, I don't have it. But if they will transpond, if they will broadcast this data, I will definitely have it.
Then that would definitely not be a UFO. Wow, that's so weird.
That is absolutely amazing.
The cells are. Yeah.
And the amount of detail is really great. For example, if I filter by A380, this is just the usual stuff, airports that are capable of having A380. But if I go to France and near Toulouse,
Yeah.
I will see where these A380s are tested. So this interesting trace, when they just fly and then turn around and go back, it is a place when these new A380s have been tested. Unfortunately, there will be no new A380s anymore.
Alexey, how long have you played with this?
Many, many days.
What would you say is the most useful insight you got from
The most unusual insight.
any insights? Resource
Quite a lot of them. Like, let's zoom into the place when there are many A380s. They are particularly popular in the Emirates.
Yeah.
And let's zoom in.
Whoa, did you see that spiral?
Yeah, and there is some interesting spiral, and probably it's a demonstration flight to maybe some exhibition, maybe some, I don't know, public event when they do interesting stuff using their fleet. And also you can see, so here is an airport, but what is this ball of hair?
Parking lot?
Let's take a look. It's some hangar, yeah. And if we switch to the map of all airplanes, Boeing, Airbus, you can see that these hangars are dedicated for Airbus, and probably there should be another. And interesting that some parking lots are used mostly for Airbus, some mostly for Boeing. And also I can color by a hash of airline. And there are just places typically used by one airline and places used by another airline. But there is a lot of stuff like different countries that are popular for air gliding, sport or entertainment. some countries where it is not popular at all. Like, let's switch to gliders. And you can see
Very German and British.
German, yeah, Netherlands, British, but surprisingly not France. Or at least not a lot in France. Not Spain, I don't know. Maybe different laws. Not many in Poland. Interesting if I switch to, do we have drones? I don't see it. Maybe ultralight.
Different ultralights and transmitters.
Yeah, interesting. Where are the drones? And if we go to Israel, we can see a lot of ultralights not vehicles, planes. And let's take a look what type of planes. Yeah. So this is probably not a drone, but this looks like. So I don't know exactly, but most likely patrolling vehicles. Let's again switch to. This is interesting. If we look here, we see some flying stuff, those circles in the ocean. And this is probably not that. Let's filter a little bit better. What is this? It's unclear, but identified as Mahaz. What is Mahaz? I don't know, something interesting. Okay, we can play infinite time. Yeah, thank you.
We'll go home and do this.